Greetings, M squared here. Today we're going to talk about segment addition postulate. So in class we talked about two different postulates, the segment addition and the angle addition postulates, but I'm going to make two videos. So if you need help on the angle one, catch the next video. So segment addition postulate basically tells you that you can take a segment and split it up into parts, and when you do, this part plus this part equals the whole thing. Now, intuitively, you know that, but sometimes when we start adding x's and different things, it gets confusing. That's why it's super important to always write your formula down until you get really comfortable with it and until you can see which part is represented by which. So I'm going to use this formula and this segment for each of my problems. Obviously, if you're doing this on homework, you're probably going to have, different maybe segments. So just always make sure you write your formula. So my formula is AB plus BC equals AC. So before I start doing the problem, I'm going to actually write that down. So whatever your segment is, you're going to write that formula down. And then you're going to look at what they give you. So in this case, they tell me that AB is 20. Remember, AB is the distance between point A and point B. So I know that that's 20. And then BC is 80, so I plug that in for BC. I'm just substituting those numbers because that's in for what they equal, a substitution property. So here we go, that equals AC. And then they actually ask me to find AC. Well, obviously, if 20 plus 80 equals AC, then 100 equals AC. So that's pretty straightforward when we plug it in. Now over here, we want to be careful. We always want to use the formula. Make sure if you aren't using your formula that you're careful as to what part is equaling what part, because you'll notice here that they give me AB again, but they don't give me BC. They're asking me for BC. So I'm going to leave BC in my formula, but I'm going to plug in 58 for the AC. And now I need to solve for BC. So it's kind of like just when an X is there and you're solving a linear equation, we're going to subtract 14 from both sides like that. And we're going to find that BC equals 44. All right, now moving into equations that have variables. So we're going to do two different ones. We're going to do one that's linear, and we're going to do one that's quadratic. And we solve those two differently. So first of all, like I said, I'm always going to write this formula because that will help me know what part to plug in for what part. So I see that AB is 3x minus 8. So I take out the AB and I put in my 3x minus 8. And then I'm going to add BC, which is 14. And finally, I'm going to plug in 6x minus 21 for AC. Then I'm going to look at that equation. I notice it's linear because I don't have any x squareds. That means I need to get all the x's on one side. So I like to move my x's to where it's positive x's when I'm done. So since 6x minus 3x is going to be a positive number of x's, I move it this way to the right instead of that way, which would give me negatives. You can move it either way, but I like to make it positive so that I don't have to divide later by a negative. And at the same time, I'm going to notice that these two right here are like terms. So I need to combine them. And when I combine 14 and 8, I get a 6. Because 6 plus 8 is 14. 14 minus 8 is 6. But I still have a 21 over here. Since I chose to get all my x's on the right side, I'm going to have to move my numbers to the left side. So I'm going to add 21 to both sides so that I can get all the x's on that side. And 21 plus 6 is 27. And my final step to get x alone is to divide both sides by 3. And when I do that, 27 divided by 3 is 9. So when we're used to solving equations, sometimes when we get x, we think we're done. Always go back and make sure you remember what they're asking for. They actually asked for AC. And up here it says that AC equals 6 times x. I'm going to scribble that out. 6 times x minus 21. But instead of x, I'm going to put what I've just found x to be, which is 9. So AC equals 6 times 9 is 54 minus 21, which means AC is equal to 33. Because 5 minus 2 is 3, 4 minus 1 is 3. So AC equals 33 is my answer. So that's how to use the segment addition postulate to solve a linear equation. Now we're going to do it to solve a quadratic equation. And remember, that's a little different. We're going to solve this quadratic equation. We're going to simplify it, get everything on one side, and then we're going to solve using factoring. If you have learned other methods to solve, you go right ahead. But in my class, we are not going to use any of the other methods. We're just going to use factoring. So first I'm going to write my formula down, and then I'm going to substitute. So AB is 9x minus 7, and I'm going to add it to BC, which is 8x minus 3, and that's going to be equal to AC, which is 3x squared plus 10. And that little squared is how I can tell it's quadratic. Now in a quadratic equation, I'm going to simplify and get everything on one side. So first I'm just going to simplify this left side. I can't combine these because they're not like terms, but I can combine these x's and these numbers. So 9x plus 8x is 17x, and negative 7 minus 3 is negative 10. So that's the first thing. And now I want to get everything on one side, and I want my x squared to be positive. So I'm not going to move it to the left side. I'm going to move everything to the right side. I'm going to do this at the same time. I'm going to add 10 and subtract 17x at the same time. And when I do that, I get 0 equals, and that's important that 0 equals. Without it, I can't factor and use my 0 property rule. So I want to make sure that you know that that is an important piece of this puzzle. 17x is just negative 17x. I couldn't subtract it from any x's because there weren't any, so it's just going to be like that. But I can do the 10 plus 10, which is 20. So if you remember, we're going to use our box method to factor this. We are going to get two binomials that multiply together to get 3x squared minus 17x plus 20. But before we do that, we're going to multiply our a times c, which is 60x squared. And what we need to do is find two factors of 60x squared that add up to negative 17. Well, that means I'm going to have two negatives, so I'm just going to start with, I'm going to start with negative 6 and 10 and see how that goes. So negative 6 and 10 definitely equals 60x squared, but when I add them, I get 16, not 17. Wow, I'm really close. So let me try 5, because I'm super close. 16 is super close. So if I did 5, that means I would have 12x. I think 5, yep. And oh, that is it. That adds up to 17x. So this is when I make my box. And remember, I always put the ax squared in this box and the c in this box. And then I put these two things that I got from my little finding out what factors of this equal that. I put those over here in these boxes. And then I'm going to take the greatest common factor of each column and row, and eventually that's what goes in there. So the greatest common factor of these two would be 4, and the greatest common factor of these two would be x. These two would be 3x, and these two would be 5. The problem is that I didn't get any negatives when I did that. So I have to know that these two are going to have to be negative in order for me to get a positive 20, because a negative 5 times a negative 4 is 20. And also to get a negative 5x, I would have to have a negative, and the negative 12x. But I'm just going to check real quick. Yep, I think we're good. So over here, we're going to put in this in one of them, and this in the other one. Now I'm not done. I've just factored it, but now I have to solve. And what happens here is there's this 0 property rule that says something times something else, if it equals 0, one of those two things would always have to be 0. So I have to say, okay, when does x minus 4 equal 0? Well, that happens when x is 4, right? 4 minus 4 is 0. So one of my answers is 4. When does 3x minus 5 equal 0? Well, that's a little bit more complicated. I'm going to have to get the x alone. So 3x equals 5, and then I'm going to divide by 3, and x equals 5/3. So now I have two x's. But they didn't even ask me for x. They asked me for AC. So I have to plug both of those back in here to actually find my AC. And if I have two answers here, then I'm going to have two answers up here. So first I'll try my 4. What's 3 times 4 squared plus 10? Well, 4 squared is 16. 16 times 3 is 48. And 48 plus 10 is 58. So one of my ACs is going to be 58. And then I try the 5/3. When I do my 5/3, I'm going to get 3 times 5/3 squared plus 10. 5/3 squared is 25/9 times 3. The 3 and the 9 are reducible. So I'm going to say 3 goes into 9 3 times. So now I have 25 thirds plus 10. And I can either change them all to fraction, like an improper fraction, or a decimal would be tough. I can do it a mixed number and improper fraction. Basically, that's what I'm going to get. So I'm going to change my 10 to 30 thirds, because 30 divided by 3 is still 10. Now I have 25 thirds plus 30 thirds, which gets me 55 thirds. So another option for my AC is 55 thirds. So that is how you would use your segment addition postulate to solve equations. Good luck with that. M squared signing out.